Okay, so today we're going to review a little bit of angle of elevation and depression. So you did see this back in geometry. So I'm going to go through a few things just from the first and second page. So all the example up to 6. The application practice page, so the second one, all of this is extra practice for you. And I gave you guys the answers at the bottom in case you need them. So if you want to do that last page later, cool. If not, I mean, you know it's there in case you need it. Okay, so last class period we were looking at solving right triangles. We didn't find any angles because I knew we were covering this today. So if you were wondering, how do I find an angle from a triangle? Congratulations, that's the first 3 questions. So you're going to need SOHCAHTOA for the first part. And if we're going to find an angle, we need to know how to actually identify which trig function to use and then how to actually find that angle. So we're going to look at letters A and B. So for letter A, I have my triangle. It has theta up in this top corner. And I need to figure out, do I need to use sine, cosine, or tangent? Which one? Cosine, because we have the adjacent side and we have the hypotenuse. Directly across from your 90-degree angle is 9. That's your hypotenuse. So we're going to use the cosine trig function. Cosine of theta is going to equal the adjacent over the hypotenuse. If I wanted to solve for theta, I need to do something to cosine to get rid of it. I'll give you a hint. You cannot divide it. What's up?
Do cosine to the power of -1
Cosine to the power of -1. That's the inverse. So cosine inverse on each side. So instead of doing cosine, or dividing it, we're going to do the cosine inverse on each side. When you do that, the cosines are going to cancel, and it's going to leave you with theta will equal cosine inverse of 4 over 9. So if I didn't give you a calculator on your test or quiz, you could just write this out because this is technically what your angle will be. But since you have a calculator, I'll show you how to use your scientific one first, and then I'll show you how to use your graphing one. So in your scientific calculator, you're going to type in the ratio first, so the fraction. So we're going to type in 4 divided by, not 6, let's do 9. So 4 divided by 9 first. Hit enter. And then you're going to do cosine inverse. Cosine inverse is when you push the second button and then cosine, because right on top of cosine should be the inverse function. So you're going to hit second cosine, and this decimal will give you your angle. So I'll do that one more time. I did 4 divided by 9. I'm going to push the second button, and then for me, cosine, because cosine inverse in green is right on top. So the angle should be about 63 degrees. I'm going to approximate that for this whole page. We're just going to round it to the nearest tenths place, so 1 decimal place. So 63.6 degrees. That's that angle measure that I'm looking for. Questions or concerns? All right, let's look at part B. Part B, again, we have a triangle. Jacqueline, what's the trig function that I should use for this? Tangent, good. Right across from the 90-degree angle is literally nothing. So I could try to find that missing piece, but you don't have to. We're going to use tangent of theta, and that's going to be opposite, which is 10, over the adjacent, which is 8. I will make a note for this. You do not need to reduce that fraction. Just leave it as 10 over 8. If you reduce it, it's not going to change your answer. How do I get rid of tangent this time? I can't divide. To the power of -1. So do the inverse on each side. Tangent inverse. So we're going to have theta equal to, I'm going to use my scientific calculator again, since we already have it out. Let's use 10 divided by 8. And we're going to do the tangent inverse. So the way I'm going to do that is green tangent, and this should be my angle. So let me rewrite what I just did. We did tangent inverse of 10 over 8. And theta is equal to 51.34019, which is approximately 51.3 degrees. On your tests and quizzes, I'll definitely tell you how many decimal places to round to, but for now, we're just good with writing out what we have. So just round it to the nearest tenths place. Okay, so I wanted to kind of refresh your memory a bit on what we did there. Let's go ahead and kind of skip ahead. You guys can easily do C later on if you want to. But let's look at angle of elevation and depression. So with angle of elevation and depression, you're looking at a specific object, or something is looking at an object, and you're trying to figure out, is it elevating or is it pretty much depressing, which is going down. So for angle of elevation, an idea or kind of a way you usually see it is somebody or something is looking at an object that's above them. So for instance, like a bird in the sky. I'm going to do this disclaimer right off the bat. I am not an artist. I went to school for math, not art. So if I do not draw nicely, I do apologize. So with the object that you're looking at, I usually draw a line of sight that the person has. So I usually just draw that kind of so that way you can see. That's where their line of sight normally is. What makes it an angle of elevation is that they have to look up to see that bird. So the angle that's created here is your angle of elevation. This theta is your angle of elevation. Same thing for angle of depression. This time, instead of looking up, you're looking down. So, okay, obviously we can't fly, so we're going to use like a bird that's in the air, and it's looking at some bug or some worm on the floor. Here's the ground, that's where the worm is, and you're trying to look down. So the bird's line of sight is directly in front of it, and its angle of depression, which is where it's looking, is going to be straight down here. So this little angle will be the angle of depression. So whenever it's looking down, that's angle of depression. When it's looking up at that ridiculous little worm I just drew, that's your angle of depression. So these are the things we're going to be finding. Sometimes they're really easy and simple to identify where the angle of elevation is, where the angle of depression is. And then other questions like you're going to see before you guys leave is how it will kind of be written on your tests and quizzes more than likely. Okay, example 2 is really simple. It's a very softball type question for geometry. So it says a giant redwood tree casts a shadow 532 feet long. Find the height of the tree if the angle of elevation of the sun is 25.7 degrees. Okay, so let me draw out what I have. I have my tree. That's my tree. And it's casting a 532 foot long shadow. So let me kind of shorten my tree a bit. Here's its shadow. This is 532 feet. It asks you to find the height of that tree if the angle of elevation of the sun is 25.7 degrees. Okay, well, the wording on this is a little ugly, but the sun is usually, especially if it's creating this long of a shadow, it's probably right behind the tree somewhere. And if it's creating an angle of elevation of 25.7 degrees, that means that it's going to be this angle in this corner. So this little angle here is going to be going up 25.7 degrees. Hopefully y'all can see that says 25.7. Even though I don't explicitly state it, it's assumed that your tree and the ground are meeting at a right angle. If I did not want you to assume that, I would tell you, don't assume. I will tell you that the angle would be something different. But if I don't tell you that, you can assume it's a 90-degree angle. The hardest part you guys are going to have, and even you probably had in geometry, is drawing out the picture first. So make sure you draw it first. I can help you with fixing it while we're in class. Okay, so this is my diagram. I need to figure out what the height of the tree is. So Heidi, how do I find out the height of this tree? What do I need to do? Which trig function should I use? Either have sine, cosine, or tangent. Do you have a hypotenuse for this? No, so let's use tangent. So let's use tangent of 25.7 degrees. That's going to equal the opposite side, which is h, over the adjacent, which is 532. David, do I need to do the inverse for this question? No, I'm not finding an angle, so you don't need to do the inverse for this problem. So instead, I'm just going to multiply both sides by 532 on each side. Let me actually do that in a darker color because y'all can't see that. Let's do 532 on each side. 532. Let's go ahead and use, since you've already used your scientific calculator, let's use your graphing just to make it easier. H is going to equal 532 times tangent of 25.7 degrees. All right, so in your calculator, I'm going to turn it on. If there's stuff in here already, just go to the home screen. First thing you guys should already be doing, or should have already done, is reset. Do not push the button on the back of my calculator, because you break it, you buy it. You're going to go down to My Documents, hit Menu, and you're going to scroll all the way up. If you're like me, scroll up to Delete All, and it asks, do you wish to proceed? Push OK. Remember, in order to get this in degree mode, you can't go to Scratchpad. For some reason, Scratchpad isn't allowing you to go to degree mode, so just go into a new document. We're going to hit calculate, and can I just plug this in? Joseph, what do I need to do? You're shaking your head. So radians isn't degree? No, it's not the same mode that I need. So how do I get to degree mode? What do I push?
Go to document.
Uh-huh.
Settings and status. Document settings. And then switch radians.
There we go. If you don't do this step right at the beginning of your test or quiz, guys, you're going to mess up on your answers. So again, we went to doc, we went to settings and status, and then document settings. So I'm going to tab all the way down because I'm lazy. I'm just going to hit the tab button and go all the way down to OK. When it's successfully been changed into degree mode, you're going to see degree in this top corner. All right, so once I have that in, let me type in my calculator what I have. So we have 532 times tangent of 25.7. So it's going to give me the height of my tree. So the height of my tree should be 256.034. I'm going to approximate that to about 256.0 feet. I'm just rounding it to the nearest tens place, like I said I was going to do. So 256.0 for the feet. Okay, so we're going to go ahead and look at question number 3. So with question number 3, I want you to take 30 seconds, read it ahead, and try to draw this out without me. It's really easy for me and for you to go through these questions if you're not graphing them on your own. Graph this on your own, see if you figure out how you can draw this. It says from the top of a 200-foot lighthouse, the angle of depression to a ship is in the ocean is 23 degrees. How far is the ship from the base of the lighthouse? When I graph these out, I don't do too many things, guys. I just do a couple of things, one thing at a time. So it said from the top of a 200-foot lighthouse. Okay, so here's my lighthouse. I'm not going to embarrass myself and draw what I think a lighthouse looks like. So here's your lighthouse. I'm going to label that. It is 200 feet. The angle of depression to the ship in the ocean, so here's your ship. There's the ocean. Is 23 degrees. So from the top down to this ship is 23 degrees. So this angle of angle of depression is 23 degrees. It asks me how far is the ship from the base of your lighthouse. So you're trying to find this length. We can assume, since it didn't tell us otherwise, that this is a 90-degree angle. It's perpendicular to the ground or the ocean. But I need to figure out what to do because I don't have any angles within this triangle. What can I do besides panic and want to leave my class? What can I do? How do I know to use tangent? I don't even know what any of the angles are in here. Yes, use geometry. What part of geometry? Say it again? No, that's the one y'all always want to pick. We talked about this a little while ago, I think, where we were showing, I should have showed you on both of the graphs here, the line of sight with the ground should always be parallel. The line of sight with the ground should always be parallel. We're definitely going back to geometry on this. So on this graph or picture, this line of sight and the ground, or in this case the ocean, are parallel. This line that I dashed in purple, which I'm now going over in black, that begins with a T. If you have two parallel lines that are cut with another one, slanted, going through it, begins with a T. What is it called? Transversal. Close enough. Transversal. What type of angles are this one here and this one here called? They're the exact same, but what are they called? Begins with an A. Nope.
Interior.
They are interior, but what type? Are they on the same side of your transversal or different? Alternate interior angles. See, we got to it. Alternate interior angles theorem. Congratulations. Welcome back to geometry. By alternate interior angle theorem, it says that your two angles are going to be the same. So this angle here and this angle here will be 23 degrees. So that's all I need from geometry. That's the only part. So we're going to take this information now and use this triangle to solve. Did you have a question? Because it says the angle of depression to the ship. You're looking from the top of the lighthouse, which is up here, down to that ship. So you're not going to use this angle as 23. That's a common mistake. Don't do it. Down here or down here? Okay, you got really lucky. When it says angle of depression, it means it's looking down. It's not looking up. If you would have given this is angle of elevation. That's not what I'm looking for. Okay, so from this, I'm going to kind of redraw my triangle a bit since it's been kind of destroyed. And I'm going to make my right angle. This is 200 feet. This is x. And this guy here is 23 degrees. All I need to do now is figure out which trig function to use. So that we don't have a hypotenuse, let's go ahead and use tangent. So tangent of 23 degrees is going to equal opposite over adjacent. What do I need to do from here? Okay, let's multiply both sides by x. So we're going to have x times a tangent of 23 degrees is equal to 200. And how do I get rid of the tangent? Because I need to solve for x. This one you can divide both sides by tangent. Okay, so x is going to be equal to, let me get my calculator out. All right, so I'm going to put in a fraction. You don't have to put this in fraction mode, but I find it easier for my brain if I do that. We're going to do 200 over tangent of 23 degrees. So that's going to be equal to 471.17, which I can approximate to 471.2. And since I found that length, is that degrees or feet? Feet, because this is a length from the base of the lighthouse all the way over to the ship. That would be my answer. So these are my two answers on my first page. Okay, so I'm going to have you guys do kind of like a similar thing. So flip it over. We're going to look at question 4. Question 4 is probably the easiest out of this whole page. So you guys can solve question 4, and it's asking you to find an angle. We just talked about how to find the inverse. You guys set this up and solve. You have a brain. You have somebody next to you. You have a question, ask them. A 40-foot ladder leans against a building. If the base of the ladder is 6 feet from the base of the building, what is the angle formed by the ladder and the building? Draw it out, see what you get. So comparing my picture to yours, does this look like what y'all have? Oops, sorry. Does this look like what y'all have? Okay, so where's the angle that you guys are finding? Is it the top angle or the bottom one?
The top.
This guy here is your ladder, correct? It says from the ladder to the building. Ladder and building. This is the ladder, this is the building. You're looking at this angle, guys. If you were going for this one down here, what is this? That's the ground and the ladder. That's not what I'm looking for. We're looking for this. Finish solving it if you haven't. So I got this part. Obviously, if you have theta all the way up here, not down here between the ladder and the ground, when it's between the building and the ladder, you're going to use the sine function. And when you're plugging this into your calculator, you should have gotten 8.62, something like this. I would have approximated this to about 8.6 degrees. Because remember, you're finding an angle measure, so make sure you put that degree symbol behind it. Units are important. All right, so I told you guys, if you finish example 4 early, cool. Try example 5. I'm going to read it to you. If you're still trying to set this up, I'll give you a little extra time. But for example 5, it says, from a point on the ground 700 feet from the base of a building, it is observed that the angle of elevation to the top of the building is 21 degrees, and the angle of elevation to the top of a flagpole atop the building is 23 degrees. You need to find the height of the building and the length of the flagpole, which is pretty much the height. Yes.
The distance from the flagpole is the same as the distance from the
Yes, you can assume that. Yes, you can assume that the distance from the flagpole to whatever point it is, I don't know what that point is, that you can assume that it's the same. So I'll give you another 30 or so seconds to draw this out. Show me what you would put on a test or quiz. Show me that. So whenever you guys are doing this, read it through once so that way you see what it's saying, and then read it one more time to actually graph your stuff out. So this says, from a point on the ground 700 feet from the base of a building. Here's your building. Here's that length to some random point. I don't know what that point is, but there it is. This distance is 700 feet, and this vertical purple line is your building. It is observed that an angle of elevation at to the top of the building is 21 degrees. So this angle of elevation, because elevation goes up, right? Angle of elevation, looking to the top of this building, that's the top point, is going to be 21 degrees. It also says the angle of elevation to the top of a flagpole. Okay, now we have a flagpole. Let's put this flagpole at the top of the building. The angle of elevation to the top of the building from that same point is 23 degrees. So here's the top of that flagpole. The angle of elevation is going to be in black. That's 23 degrees. It's asking you to find two different things. It's asking you to find the height of the building. So I'm going to label the height of the building as X. And it's asking you to find the length or height of the flagpole, which I'm going to label as Y. This is what your diagram should look like. Take it one thing at a time when you're solving it, or at least setting it up. Okay, there's going to be a couple things I need to find. I need to find X and Y. I can definitely assume also that this is a 90-degree angle because it didn't tell me that it's leaning or anything. Hopefully the building's not leaning. So I'm assuming it's 90 degrees. It's perpendicular to the ground. So first things first, I need to find one of those variables right off the bat. Jenny, which variable do you think we should find first, X or Y? We can't find both at the same time, though. Say it again. X. Okay, let's find X. So to find X, I'm going to use the smaller triangle. So to find X, we're going to use that smaller triangle, which I'm going to redraw so that way you see what you're doing. Take the time to redraw it, guys. This is 700 feet. For this smaller triangle, are we using the 21 degrees or 23? 21. And then the height is X. This is my triangle. So if I notice, I don't have a hypotenuse here. So let's go ahead and use let me look back at the front page to see what trig function. Let's go ahead and use tangent because tangent does not require the hypotenuse. So we're going to have tangent of 21 degrees is going to equal opposite over adjacent. I'm going to multiply both sides by 700. So X is going to equal 700 times the tangent of 21 degrees. All right, so let me write out my whole number and everything. So we're going to have 700 times tangent of 21 degrees. So it's going to be 268.705. I'm going to approximate that to about 268.7 degrees. Oh, not degrees, that's feet. I always want to put degrees for some reason. Feet. I solved the question, right? I'm done? What else do I still have to find? The flagpole. Okay, great. I have to find that too. Okay, so at least I now know what X is, but now I need to figure out what Y is. If I wanted to figure out Y, do I need to use the big whole triangle, or can I use this small one that I have created here? Which one should I use? I would definitely use the bigger triangle. The reason why, if you could technically use this smaller triangle if you learn law of sines and cosines. If that doesn't ring a bell, that means you didn't learn it in geometry, so I'm not going to show you how to do that just yet. It is going to be something we do go over in pre-cal though. So we're going to use the large triangle. I'm going to recopy it. And we're going to find y by using the large triangle. In this large triangle, the base is still 700 feet. The angle of elevation is not 21 anymore. We're going to use 23 instead. This height, is this height x, y, or x plus y? X plus y. It's both, because that entire length is what I have for that entire building. Especially if you're going to use the big triangle, you have to include x. Okay, so looking at what I have, Valeria, which trig function should I use? Sine, cosine, or tangent? Say it again. Tangent. Let's use tangent of 23 degrees is going to equal opposite over the adjacent, which is 700. Okay, well, I need to solve. Don't we know what x is, though? What was x? 268.7. So I can take that and plug it in. So let me plug that in so I don't get confused. Tangent of 23 degrees is equal to 268.7 plus y over 700. Okay, I'm going to go ahead and solve. I'm going to multiply both sides by 700. So 700 times tangent of 23 degrees is going to equal 268.7 plus y. And I could go ahead and compute this, but then I'm just going to get a whole crazy long decimal. Let me just keep it as is and isolate y. How would I move the 268 to the other side of your equation? Subtract. Since this tangent is here, guys, don't just start subtracting the 700 and 268. We're going to write it out as 700 times tangent of 23 degrees minus 268.7 is going to equal your y. I'm going to take all of this and plug it into my calculator. When I plug it in, guys, I'm not going to use the 268.7. I'm going to use the entire decimal that I got in my calculator. I'm going to use this whole crazy decimal. So let's go ahead and plug it in. I'm going to show you exactly what I'm typing. We're going to put 700, not 711, 700 times tangent of 23 degrees. After that, we're going to subtract it. So let me move it over. Subtraction sign, the 268.7. Don't just type in 268.7. Scroll up, highlight the last item that we have, which is the 268.7. Hit enter, and it'll copy it down for you. So it looks like y is going to equal 28.4275. What is that y value again? What is it representative of? The flagpole's height. So y is going to be approximately 28.4 feet. Make sure you put the feet with it. You could definitely compute as you go, so plug in the 700 times the tangent first and then subtract at the end, but I just like doing it all in once. It's up to you guys, though. All right, I'm literally giving you guys 2 minutes. Draw out what number 6 should look like. You have a brain. You have somebody next to you. You made it out of geometry somehow. Show me that you deserve to be in pre-calc. Come on. So go ahead and try to set up number 6. Remember, guys, I'm going to graph this one out with you guys to show you what it should look like. If this whole experience of reviewing this has been a pain, oh, congratulations. This practice will help you make perfect. So especially the last couple questions on the back side of this page, if you don't like questions 5 and 6, that's what you need to study. Okay, so let me show you guys what you should have had. A kite is floating above a straight road. So here's your road. Here's the kite. To estimate its height above the ground, the kite flyers simultaneously measure the angle of depression to 2 consecutive milestones. So that means on that same straight road, pretty much one after the other, there's 2 mileposts. Here's the first milepost, here's the second one. Simple. meaning each post is a mile apart. A mile is 1 mile. This distance is 1 mile. Okay, so it says that you have it, they're on the same side of the road. Okay, so that's perfect. The last part is the angles of depression, because he did say, so angle of depression, guys, please look up. So it's like, I guess, the center of the kite. The angle of depression has to come from the horizontal line that comes from your kite. So at that highest point, angle of depression is from that straight line, horizontal line, going down. So the first angle of depression is 15 degrees, so it's going to go down from here, 15 degrees. So I'm going to kind of graph this one out. So I'm going to go over to that first one, farthest out. And then the other angle of depression is at 31 degrees. So it's going to go down 31 degrees to that. We can safely assume that this is 90-degree angle right here. If it asks you to figure out what the height of the kite is, that's x. That's what I'm trying to find. So I need to figure out, based on this, what am I missing? Because I have my right triangle down here. What am I missing? Say it again, Fatima. Not just a side length, but look at the triangle here and the big triangle. What am I missing inside? Angles. Which angle should I probably use? Alternate interior angles. I'm not going to draw it out like I did before. This line is parallel to the ground. So your alternate interior angle for this brown or like dark brownish looking triangle, this angle down here is going to be 15 degrees. That means that this angle down here is going to be 31 degrees. So let me zoom in so you guys can see it a little better in case you're struggling. So this is our diagram. So we need to figure out how high the kite is. Okay, so we have this height. I need to figure out how to find it. Okay, so like I kind of mentioned in a prior question, this triangle here, I would have to use law of sines or cosines. There's no way for me to try to figure out the height of your kite by using just that triangle. So instead, I'm going to definitely need to use the right triangle since x is here. Okay, so I don't know, unfortunately, what this length is, but I do know that this length between both of the mile posts are both going to be 1 mile. So let's just label this as y. This is going to be about a 3 or 4 step problem to actually have me find my answers. So let me go through the first step. This one will require some space, and I realize that for me at least, my back pages aren't blank. So you might want to kind of space this out a bit, but you will probably need about 4 steps. So the first step, okay, let's look at the smaller triangle, which is here. So I'm going to redraw it. This is x, this is y, and this angle is 31 degrees. If I was to try to find x, like I would normally want to do, I would need to use tangent of 31 degrees is going to equal x over y. Okay, cool, I have that. If I was going to find x again, but for my larger triangle, so let me draw out my larger triangle, step 2. Let's draw out that larger triangle. This is x. This angle down here is going to be 15 degrees. And this length is not just 1. It's going to be y plus 1, because that's the entire length. Y plus 1. Again, I have no hypotenuse, so I need to use tangent. So we're going to do tangent of x over y plus 1. Oh, let's try it again. Tangent of, let me put my angle first, tangent of 15 degrees is equal to x over y plus 1. Much better. Okay, based on these two things, I need to figure out how to find x. X is the height of my kite. Once I find that value, I'll be good. But the issue is I have 2 unknowns. I have the x and the y. Okay, well, the y is definitely being added here, so I don't really want to try to isolate y. Let's isolate x, because x is ultimately the height of that kite. So let's go ahead and try to find x. So step 3, I'm going to put that you want to set both of these equations equal by finding your x. So in order to do that, we need to first isolate x in both of these equations. So to isolate x, to make your life easier, put this over 1 and cross multiply. When you do that, 1 times x is going to be x equals, and then you'll have y times tangent of 31 degrees. I'm going to do the same thing here. X is going to equal, because x times 1 is just x, y plus 1 times tangent of 15 degrees. So like I said, we're going to set the x's equal to each other. So set x equal to each other. So we're going to solve. So we're going to have y times tangent of 31 is going to equal y plus 1 times tangent of 15 degrees. Okay, so I have both of these equal. Obviously, I'm going to have to solve for y now. I only have one variable. Y is throughout the entire problem, so I can solve. When you're solving, you're going to distribute this y plus 1 to tangent, so that way you have two separate tangents for each of these. Because remember, both of these y's, I can't just divide both sides by y, or y plus 1, because it's not going to be able to isolate y completely. So what I mean by this, let me show you what I mean. We're going to do tangent of 31 degrees is going to equal y times tangent of 15 plus 1 times tangent of 15 degrees. And you don't need to put that 1 times, but I'm just putting it there so that way you have it. Okay, cool. Now that I have that isolated to an extent, I'm going to move this whole y term to the other side. So we're going to subtract y times tangent of 15 degrees minus y times tangent of 15 degrees. Okay, well, unlike the other problems that we've seen before, I can't just combine these. You can't just subtract the numbers or anything. You actually have to write this as y times tangent of 31 degrees minus y times tangent of 15 degrees. And that's going to equal just tangent of 15 degrees, because that 1 times tangent is just tangent. Okay, I tried to just not use another page, but I'm going to have to. So let me get a different page so that way you guys can see it. And I'm going to recopy what I had. Y times tangent of 31 degrees minus y times tangent of 15 degrees is going to equal tangent of 15 degrees. Okay, so this is my equation. I have two y's. I'm almost there. I need to actually just get one of these y's instead of two. So how do we get both of these y's to become 1? Think back to algebra 1. We're just going to factor. Tangent of 31 degrees minus tangent of 15 degrees. So from here, I have y, one y, pretty much almost by itself. It's being multiplied, or you could distribute it, by this whole binomial, which is tangent of 31 minus tangent of 15. The opposite of multiplying is to divide both sides by tangent of 31 degrees and tangent of 15 degrees. So this whole little binomial. So y is equal to tangent of 15 degrees over tangent of 31 degrees minus tangent of 15 degrees. So let me get my calculator out. I'm going to take all of this and we're going to plug it into our calculator to find our y. So I'm going to make my fraction. We're going to do tangent of 15 degrees over tangent of 31 degrees. 31 minus tangent of 15. Make sure your calculator's still in degree mode. It still is. And I'm going to be able to write that as my answer. So 0.084 is going to be my decimal. So we're going to write that as 0.0 or 0.804866. And the unit of this, let me look back. It looks like my unit is the mile, so it's a mile apart. So I'm going to put this as my miles. Okay, cool. So I have this as my mile. And if I look back at the problem was asking me to solve for what again? It asked me to solve to find how high the kite is. So that's x. Okay, well, the y is useful, but I need to find x. Remember how we isolated this equation right here at the beginning? And technically, this equation here at the beginning, we can use both of these equations really to find out what your x value is. It doesn't matter which one you choose. Obviously, I'm going to pick the easier of the two that's not being added, which is an extra step. So I'm going to recopy this as my fourth step, and I'm going to plug in what I have. So my fourth step is to make this x equals y times tangent of 31 degrees. The y value is this. I purposely am using my graphing calculator because we're going to use this whole crazy long decimal and we're going to multiply it by tangent of 31 degrees. So x is going to equal that whole crazy decimal, 0.80466 times tangent of 31 degrees. I'm going to double check my calculator is in degree mode, so I'm okay. I'm going to take that decimal, copy it down, and multiply it by tangent of 31 degrees. Multiply it by tangent of 31 degrees. So my decimal is going to be 0.48362. And this is again in miles. Okay, well, that's nice. But the issue is, I mean, this is an ugly decimal. If I really wanted to find out the height for my kite, I'd probably want to change it to something that's a little nicer. If I asked you to write your problem in miles, or if I didn't specify it, we can leave it like this. I'd probably round it to like 1 or 2 decimal places though. But especially since this is a very small decimal, it doesn't explicitly say this, but I'm going to have you guys write this height in feet. So to find your height in feet, we need to do a conversion. So I guess there's like a 5th step to this. In order to convert this into feet, right now I have 0.483612 miles, and I want to convert this into feet. You did unit conversions back in Algebra 2. You did it in IPC. You probably did it in chemistry as well, and maybe even physics. So in order to convert from miles into feet, this should not be new, guys. How many miles are in 1 foot? There are 5,280 feet in 1 mile. So all I need to do is cancel out my units, the miles. I'm left with feet. Once I multiply both of these numbers, I'll write my final answer. And I'll say it again. Technically, we could have stopped here. But since this was a very small decimal, I wanted to give you something that's a little larger so that way you could see how far off the ground that is. So I'm going to go ahead and take my decimal, and I'm going to multiply it by 5,280 feet. The calculator really doesn't need to be in degree mode because it's not really measuring a degree or anything, or an angle, but I mean, this will still give me the right answer. So I have about 2,553 feet. So I'm going to write that out as 2,553.47. And I could probably round that up to about 5 since we were saying to round it to the 10th place. So 0.5. That should be my answer. So guys, when you're doing these, I'll say it again. I mentioned it earlier. If you have had a really tough time with this video, I need you to go back to your notes, the extra page that I gave you, and all of the questions that I didn't go through here, which was really, I didn't go through any, I want you to actually try them. Especially this last page, because it will give you more and more questions that look just like the one you just solved.